My presentation about layer 2 security features, and as one already said, layer 2 is sometimes a little bit forgotten. Everyone is thinking about high security on its firewalling or on its core router for securing the internet network from outside, but sometimes filtering on the firewall is a little bit too late because something could occur on your local network. So that's the reason why I'm going to talk about layer 2 security features based on routers 7.18. Oh, have you tried to turn it on? That helps. So first of all, the usual me about myself. My name is Sebastian Inacker from FMS Internet Service GmbH from Germany. I'm also a MikroTik trainer for several MikroTik certification trainings. And this is my first professional conference, MikroTik professional conference, so I missed last year. Bad luck for me, but it's the same as at the user meetings. I also missed the first year of user meetings, so it's in straight line. Also, this is my first MikroTik presentation since 2019, and by accident, I'm wearing the correct t-shirt for that. It was Netherlands 2019. So who's from Netherlands? Perfect. I don't speak your language, I'm sorry. And for the rest of you, don't worry. I'm happy to speak English. So a little bit, only a little bit about our company. We are a value-added distributor, so we are not only moving boxes, MikroTik boxes or whatever. So we are doing distribution, we are doing training, we are doing consulting, support, workshops, talks. Company was founded in the last century, and we are located in southwest of Germany. And before you ask, I don't speak French and I don't speak Italian. Also, we are close to the border of Switzerland and France. We have 4 certificated MikroTik consultants in our company and also 2 MikroTik trainers. And you know all of us right now, it's me and Patrick from yesterday. We've quite a lot of MikroTik experience. That's the part where I'm going to feel old. And as I said, we are doing trainings and workshops worldwide. And talking about myself, I did trainings and workshops on 3 continents so far. So if anyone wants to hire me for Australia or New Zealand, you're welcome. That's missing on my list. And one personal highlight was that I was invited 2 times for Greenland, which is quite an exotic business trip. That's all for the boring part. So let's start with a preface, what you are going to expect. I'm going to give you, of course, an incomplete overview of layer 2 security features. So for example, I'm not going to talk about .1x at all because there was a presentation yesterday. And it will be a quite fast overview of the available features. Again, an incomplete feature list, and I'm going to focus on some details. Presentation is based on routers version 7.18. Screenshots are from Winbox version 3. Sorry, I'm old-fashioned. And, well, at least the last one is just the date. So let's start with one classical feature, VLANs, which I'm sure you already know about. I just wanted to show or make you aware of a feature which came in routers version 7.17. And since routers version 7.17, you're able to use interface lists for your bridge VLAN configuration. So if you created a VLAN configuration or bridge VLAN configuration, you know you create a VLAN VLAN ID 100 or whatever, and you just add all your trunk ports or your tag ports, for example. And that could be made much more easier, in my opinion, with an interface list. So as a preparation, you are creating one or multiple interface lists. So for example, you have an interface list called trunk, an interface list called VLAN 100, VLAN 200, or whatever. And all you have to do is you assign interfaces to your specific list. So if you have, for example, 2 or several interfaces for where you have to send tagged traffic, so your trunk ports, for example, just add the specific interface to your interface list named trunk. Then you create or add ports or all relevant ports to your interface list VLAN 100, VLAN 200, and so on. And the nice thing, in my opinion, is if you create your VLAN 100, for example, you don't have to mention SFP plus 1, SFP plus 2, 3, 4, Ethernet 5, Ethernet 6, whatever. You just add tagged interface list trunk, and every interface which is in your interface list will be included in your VLAN 100 as a trunk port or as a tag port. Yeah. And by surprise, since routers version 6, you're able to use interface lists for your bridge ports. Maybe you've already seen when you created your bridge VLAN configuration and you add Ethernet 5, for example, to your VLAN 100 or whatever, you will receive a message, Ethernet 5 is not a bridge member. But if you use interface lists for your bridge ports, you will never miss one port because it will be in the list or it will be not in the list. If it's not in the list, you don't care about it. So all you have to do is you're going to bridge ports, and instead of giving a specific physical interface, again, you're using the interface lists you already created for your VLAN configuration, assign it to a bridge, and on the VLAN tab, you say, okay, interface list VLAN 100 should be VLAN 100, and I only want to admit untagged or priority tagged ports. The result will be, as you see here, your bridge ports list. And if you can see or see it here, you will have static interface or interface lists as a member of your bridge ports, and all your interface lists members will be dynamic ports, and hopefully they will hardware offload it. And as you can see here, for the interface VLAN 100 or 200, you can see the pWidth is set to 100 or 200, so whatever you have configured on your bridge ports configuration. I think that's quite a cool feature, which came in routers version 7.17. Next feature I'm going to talk about is ACLs, or access control lists. And the nice feature about access control lists, or of an access control list, is that you have, or you could have, wire speed filtering of your traffic. And if you're thinking about ACLs or ACL rules, you're not limited to layer 2 options. You can also use layer 3 options. So for example, you can filter HTTP, HTTPS, or whatever features or other options, again, in wire speed. And as already mentioned, filtering at the core router might be too late, because all the packets that will be deleted or rejected or denied on the firewall have gone through your complete network, however large that is. Again, it's wire speed filtering, but be careful, it's not stateful firewalling. So don't drop the returning packets. So if you're used to firewalling on layer 3 on your router, you are used to, okay, I will allow established packets. That's not available here. So just think about the returning packets which are coming back from maybe the internet or whoever you are talking to. When you are using the ports condition on your ACL rules, the ACL rule will just match incoming traffic on that port or on that list of ports. And yeah, the important part is how many ACL rules can you apply or can you set. It depends on your hardware, or it depends on your switch chip. So as you can see on this really incomplete list of different switch chips, you'll see that you have ACL rules ranging from 128 up to 1024. And some exotic numbers, 170 or 682 rules. Don't know why this number is available, or not one more, not one less, but you have to take care how much rules you can use on your specific hardware. Maybe 100 rules is more than enough, depending on what you're doing. So what's going to happen if you have an CS 326, for example, which, as you can see here, only supports 128 ACL rules? What's going to happen if you have add ACL rule number 129? So if you try to add more ACL rules than your switch is able to handle, you'll see the device will tell you, sorry, I only support 128. So you don't have to worry, maybe my ACL rule 129 will be ignored or skipped or used in software. It will just deny the creation of that ACL rule, which is good or bad. Well, I think it's good. And to give you a first example of an ACL rule or a set of ACL rules is, maybe you only want to allow web access from specific ports. So maybe you're going to allow HTTPS, so encrypted web surfing, and HTTP. So, well, as I told you before, you're not limited to layer 2 functionality. You're also able to use IP protocol filtering or options or conditions. So you set the protocol, for example, to TCP, port 443 or port 80. These two ports you want to allow on Ethernet 1, 2, 3, 4, 5, for example. And as a last step, you just drop or deny everything else which was not accepted before. But again, you have to be careful. Don't forget DCP or DNS or ARP. Because if you only accept HTTP and HTTPS and drop all the rest, well, IP version 4 without ARP, you can try, but it's not going to work. Web surfing without DNS, not a good idea. So take care, and you have to accept, well, it's easy. You have to accept everything you need to bring your customers online. Sounds easy, it's not easy all the time. Different example for an ACL rule is, maybe you want to allow only PPE traffic from your clients or from your end users. So I've seen someone, or some of you are ISPs who are using PPPoE, for example, And if you're an ISP and you offer only PPE service to your customers, there's no need that your customers doing DCP or whatever into your network and using your network as a layer 2 switch. So you only want to offer PPE in direction of your PPE server. So allow MAC protocol PPE and PPE discovery, and then you could drop the rest. Or you can say, okay, I'm going to allow PPE connections, and everything else will be sent to a new VLAN or to a specific VLAN 200, for example, and will collect everything which is not PPE in your VLAN 200. So maybe a network with a hotspot system or really reduced bandwidth, or maybe just a plain website which is shown to your users. Please use PPE because you have to. Also, which you can see here, you can accept, for example, PPE only from a specific hardware vendor based on the vendor prefix of the MAC addresses of your end user device. So, for example, if you want to have a filter on a vendor starting with 00, 0C42, which is owned by MikroTik, you can set that as a source MAC address. The first block will be the vendor prefix. The rest will be random, so selected by the ISP. So you don't want to mention every single MAC address of your customer device. So you can use a MAC filter on the second red box. This just means the first 3 blocks will be fixed. The rest I don't care about. So everything which is starting with the correct vendor prefix will be matched by this HCUL rule, and if it's PPE, it will be accepted or not dropped. If you are interested in a list of MikroTik vendor prefixes, you can see it on the URL on the bottom of this page. I'm sorry, it's a German web page, but the list is just a list of, I think it's about 19 prefixes for MikroTik or for Waterboard. And it's updated once a week. I think it's updated today, maybe in the morning or in the evening, but it's updated automatically once a week. Next thing is I'm going to present or wanted to make you aware of is port mirroring. So sometimes you are asking yourself, what's that device doing? Or I have to see what the specific device is doing, or I want to know exactly what's going on that specific port. In the really, really early days, you would connect an Ethernet hub, which is going to send traffic to all ports, but luckily Ethernet hubs are not quite used anymore, hopefully. And to have an opportunity to see which traffic is sent on a specific port, for example, is port mirroring. And as you can see here, that's a big picture of the next slide, or of the next screenshot of the Winbox configuration. You have maybe a laptop connected to Ethernet 5, and you want to see every traffic, every packet, every single bit and byte on your monitoring server, for example, in intrusion detection system. So everything going in or going out on Ethernet 5 should be sent to SFP plus 2. But as you can see, or maybe hopefully can see here, if you have a 1 gigabit port and you want to mirror incoming and outgoing traffic, you could end up with 2 gigabit of traffic. So keep that in mind. Configuration is, as many features I wanted to show you, quite simple. On switch ports, You select your Ethernet port you want to monitor or you want to mirror. You select, do you want to mirror ingress or egress traffic? So you can decide if you want to see both directions. And on switch settings, you specify a mirror target. As a mirror target is just the interface your mirrored traffic will be sent to. But again, 1 gigabit of traffic bidirectional will result in 2 gigabits of traffic, and you have to take care of, can you handle 2 gigabit of traffic? So for example, if you have an intrusion detection system, it might be quite complicated to handle 2 gigabit or even more gigabit of traffic in your intrusion detection system. So keep that in mind. Also, if you take a look at this picture here, oh, damn, I have to connect the monitoring server directly to the switch my client is connected to. That's not possible in each situation. So maybe your monitoring system is sitting in your central office and you want to monitor one device deep in your network. And that's a new feature. You can use so-called RSPAN, so remote switched port analyzer. You could just say on your switch your monitoring device is connected to, I want to send all the monitored traffic VLAN tagged through your complete network. So from one switch through your switch network to your monitoring server. By the way, that might be a good argument. Yes, you need 100 gigabit in your switch backbone because you will have, or you might end in quite a lot of traffic. Again, configuration is quite easy. You have already seen it on the previous slide. And if you take a look at the screenshot on the right side, mirror target, you know about that. Just enable RSPAN, so remote switched port analyzer, specify a VLAN ID, and then your mirror traffic will be included in a VLAN with ID 900 or whatever, and will be sent through your network, and you can analyze it somewhere in your network. You will just forward VLAN 900 through your network into direction of your monitoring server. And on the left side, you will see a little hint, ACL rules. You can use an ACL rule, and on ACL rules you cannot, or you can do more than drop or accept, but you can select mirror. So you can have an ACL rule and specify what do you need to know on the other end of your network, for example. So for example, just mirror only, this is a DNS request from your client. So maybe you just want to know what kind of DNS request is this client doing. So create an ACL rule, specify UDP port 53, set mirror and mirror it to wherever you want to have it. And as you can see here, you can see the packet which was sent out by the client or received by the client depending on your ACL rule on your monitoring device or your monitoring server. Okay. Next chapter will be a combination of WireGuard and VXLAN. So you can have a secure layer 2 network over a routed protocol, so layer 2 around the world. So a few words about WireGuard and VXLAN. I'm not going into any detail on WireGuard. It's just a modern VPN. But you've seen a different presentation about WireGuard. It's just a modern VPN solution. And VXLAN is just a layer 2 capable tunnel, which is routed by IP version 4 or IP version 6. So as soon as you can reach your tunnel endpoint by IP4 or version 6, you can use a VXLAN tunnel for a layer 2 tunnel. One additional feature which I'm not going to use anyhow is with VXLAN you are able to use up to 16 million IDs. So if you need more than 4,096 VLAN IDs, VXLAN could be an option to have quite a lot of more VLAN IDs or IDs for your separation. So that's an example for a routed WireGuard secured layer 2 connectivity between two devices. So you could have a router here in Prague, one router at our home in Freiburg. Both are connected to some network, so maybe the internet, so quite an unsecure network. You create a WireGuard tunnel between both devices, and on top or included in your WireGuard tunnel, you have a VXLAN tunnel, which is bridged with the local interfaces of your routers. And as you might see here on the cloud on the left and on the right, it's the same layer 2 network. So the good thing is you will have the same layer 2 network on both sides. And the bad thing will be you have the same layer 2 network on both sides. So exactly what you want to have, or maybe you have to take care about broadcast or whatever. What do you have to implement such kind of VXLAN tunnel? Not much, as you can see here. You just need a network identifier, just an ID, a unique ID for your tunnel. So if you have more tunnels, you have to set specific network identifiers. Well, set support for receiving and transmitting packets, UDP packets. For the local address, I'm going to use the IP address which is on top of my WireGuard tunnel. And the remote address will just be the IP address which is on top of my WireGuard interface on the different side. So my tunnel is just going through my WireGuard encrypted tunnel. Let's see, what kind of bandwidth or throughput could you expect with an VXLAN going through a WireGuard tunnel? Just to have some numbers. For example, if you have an hex refresh, which is quite a cheap device, you can see here, you can reach up to 100 to 80 megabit per second bidirectional traffic, so not 100 megabit per second TCP in one direction and then 80 in a different direction. It's simultaneously, so you can send and receive up to 180 megabits per second aggregated throughput. But that's our test results. So in your real life, you might see different or lower values, but sometimes it's quite important to see, will I reach 100 megabit? Will I reach 200, 500, or whatever? If you need more than, or at least 100 megabit per second, you could use an HEP-AX2. And as you can see here with an router board 5009, you will reach up to 700 megabit per second aggregated throughput, which is quite a good number, I think. What's also coming with routers version 7.18 is initial hardware support on specific devices for VXLAN. So you're not going to do VXLAN tunneling in software, but in hardware. But keep in mind, it's limited to 3 specific switch chips. So on the bottom of the slide, you can see currently supported devices. So you will see CCR 2116 and CCR 2216 are supported or are supporting VXLAN in hardware, and some of the cloud router switches, not all. So you have to take care that your switch you're going to use or you want to use is going to support VXLAN in hardware. Also, you have to take care of hardware accelerated or hardware offloaded VXLAN does not support VLAN tagging. So you can't send tagged traffic on your VXLAN, on your hardware accelerated VXLAN. So you have to have one VXLAN interface for each of your local VLANs. And for the tunnel endpoint, your tunnel endpoint can't be on a VRF. Okay, I don't care. But it also cannot be on IP version 6, and it can't be on VLAN. Or it cannot use equal cost multipath routing, so you're limited to some, I think you're limited to just plain, quite easy, trivial IP routing. What do you have to do to create such an hardware offloaded VXLAN? First of all, well, take care of the hardware you are going to use. So take note that your hardware is supporting hardware offloaded VXLAN. But if that's given, it's really easy. You go to interface VXLAN, you specify the bridge your interface should be included to, you specify the pivot, and you select, okay, hardware offloading, please do hardware offloading. The result will be that you have an interface on your bridge ports, a dynamic interface, your VXLAN interface, and as you can see here, oh, good luck, we have hardware acceleration. What is the benefit of hardware accelerated VXLAN? So here's a test. 2 switches which are going to support hardware accelerated VXLAN. Both switches are created a routed VXLAN tunnel through 2 router boards 5009. The routers are going to create a WireGuard tunnel. So again, the connection is encrypted by WireGuard, but the VXLAN tunnel is not terminated on the routers because they don't support hardware VXLAN, but it's terminated on the switches. And as you can see here, 900 megabit per second, or even more. Also, please note, the test device here for this throughput testing is connected by 1 gigabit. I really wanted to repeat that test with a 10 gigabit Ethernet connection, but, well, service contract customer called with a big network issue, and bad luck. I haven't had the time to repeat that test, but as you can see here, even if your device is only connected by 1 gigabit, you can reach more than 900 megabit per second bidirectional traffic throughput included in the WireGuard tunnel. Please note, also I increased the MTU of the interfaces a little bit to get these high numbers, but as you can see here, you can do that over a routed network like the internet. You will receive lower numbers, but you can also benefit from the hardware acceleration of the VXLAN on the switches. So you don't have to do that in software, but you can do that in hardware on your VXLAN hardware supported devices. Next topic I'm going to talk about a little bit is MikroTik. let's take a look at the features and hardware limitations for that. MikroTik is an IEEE standard, so it don't have to be a MikroTik device on the other hand or on the other side. By the way, for WireGuard and VXLAN, you don't have to have a MikroTik on the other side also, but MikroTik is just a standard. To have encryption over Ethernet. So even if you're going to use unencrypted protocols like HTTP, ARP, DNS, or whatever, maybe Telnet, but you don't want to use Telnet anymore. But if you're using unencrypted protocols, it will be encrypted on the Ethernet side, and many times it's used if you have an Ethernet connection between two sites and you don't have control about the line. So someone could be between your points and just mirror traffic. And when you have an encrypted traffic, and mirroring is not so easy. Situation on routers is at the moment it's in an early stage, and you don't have any hardware support at the moment. So you have to use a device for doing MikroTik, which is able to handle that amount of encryption in software. The good thing is you can use your MikroTik interface, which is resulting of your configuration, as any other interface. So you can do routing, bridging, whatever. And as you can see here, well, it's in layer 2 encryption protocol. So I'm going to use CRS 326. Use MikroTik between both devices. 15 megabit per second, 50 megabit per second. No. The CRS 326 is just the wrong device for that. Don't use that for MikroTik, at least if you have to have bigger throughput on your encryption devices. And again, an example with an RB 5009, which is quite an incredible board, by the way. As you can see, now I was able to do the bandwidth testing with 10 gigabit connections. And both water boards 5009 are connected by 2.5 gigabit per second, and doing encryption, doing MikroTik encryption in software, you can reach up to 900 and a little bit about 1 gigabit per second on throughput. Just to have a number what you could expect. So do I have to expect 100 megabit, 200, 500 gigabit, 2 gigabit? So that's just some numbers for you to have an idea what you could achieve with your setup. Last thing is some restrictions for your local user communications. And one thing is I want to show you is what you might already heard about is DHCP snooping. Because what this is used for, you don't want your end users to connect DHCP servers on your network. So once we had a customer who bought maybe 10 routers, 10 MikroTik routers, and we should configure them remotely. So first thing is the customer just connected all that 10 devices with Ethernet 1 to his network. And if you know MikroTik default configuration, Ethernet 1 is firewalled, so no lock at all. So he learned, okay, I don't have, or I can't use Ethernet 1 to connect the devices to my network. What did he do? You can guess. He connected all 10 devices with Ethernet 2 to his company network on a Friday. On the next business day, he came back and he's seen, all my PCs, my laptops, my devices are all getting some random IP addresses, 88 or whatever. Well, what's happening? He just created 11 DHCP servers in his company network. You don't want that. And one thing to detect this kind of issues is you can use IP DHCP server alert. And on IP DHCP server alert, you can specify valid DHCP servers, which are known to you because it's your DHCP server. And if some random packets from unknown DHCP servers are seen on the network, it will send an alert or it will list your unknown DHCP servers. And as you can see here, you'll see a log entry. But that's only detection. You know, okay, I have a problem. So what could be done? You could use DHCP snooping. And for DHCP snooping, you specify, do I trust that specific port? Because is it in my control or is it in the control of an end user or an end customer? So quite easy, I think. Trust your managed ports and don't trust ports where anyone is able to connect anything. And if you specify trusted or not trusted ports, the end user could connect an unknown or an unwanted DHCP server to your network, and it will be ignored. Configuration, again, quite easy if you know about that feature. You're going to your bridge configuration, you enable DHCP snooping, and on your bridge ports, you specify, do I trust that port, yes or no? It will create a dynamic ACL rule for UDP 6768. Was it? And as soon as you enabled DHCP snooping, you can add DHCP option 82. You already know about maybe. And the benefit of option 82 is that you can see the switch port and the switch name your DHCP client is connected to. So on IP DHCP server leases, you'll see, okay, IP address, whatever, was given to a device which is connected to a switch called switch 1 on Ethernet 5. Also, you might want or don't want to have layer 2 connectivity between your end users. So for example, if you're an internet service provider, for example, and your end users or customers are connected to your switches or to your switch, you don't want to have a layer 2 connectivity between customer A and customer B. Because if it could end up that they are going to play online games using your switching device as a medium for transmitting packets from their flats, for example. Or if you're in a hotel, or if you have a Wi-Fi network with a client isolation, you have to take care that customers are not able to communicate to each other on layer 2. And for that to be implemented, again, quite easy, but you have to do it. You go to switch, port isolation, you select your switch you want to limit, and if you double-click your physical device, your Ethernet device, or your Ethernet interface, you set forwarding override, forward to SFP, SFP plus 1, or multiple interfaces, and then, in this example, Ethernet 5 is only able to send traffic to SFP plus 1. And, to be quick, you also don't want to have end users able to connect any device like switches to your layer 2 network. Because if they just plug an unintended switch into your network, it could become the new root bridge in your RSTP network, for example. And you don't want that. To prevent that, you just could set a so-called edge port, but what can be done in addition, you can set up a so-called BPDU guard, which is looking for BPDU packets, and if a BPDU packet is seen, it will disable that port. Well, you have to enable it by yourself, but you can talk to the responsible person, and maybe you want to explain why it's not a good idea to do that. And, well, maybe he will call because he's offline, and you know why he's offline. As the last slide, don't worry, how do you do that? Again, it's quite simple. You're going to your bridge port. On the SDP register card, you can enable a BPDU guard, and the result is, as soon as some RSTP capable switch is connected to your Ethernet 5 port, it will send you a log entry, give a comment on the port list, and it will say, hey, port is disabled because I've seen a BPDU packet on that port. And I'm 1 minute and 43 seconds left. So thank you. Thanks for your attention.